Welcome back to the second part of our overview presentation of the SETScan Patternator. In this second part, we will do part 2, which is the operational overview with examples. First, we will look at how to operate the SETScan Patternator. Here, the SETScan Patternator can be seen sitting on 3 stands, and what we want to show you is how easy it is to operate this particular patternator. The SETScan patternator has a nozzle that is mounted on a nozzle arm. You move that arm to the center of the patternator and then you start spraying. Once you start spraying, the SETScan patternator collects the extinction caused by the spray at 6 different view angles. The spray itself is exhausted downwards and goes out so that you do not have lot of mist hanging in there. This particular model is the SETScan OP600 patternator, and it can look at sprays that as wide as 7 inches in diameter. So, you can see the lenses and the lasers in there. Next, we can look at the graphical user interface that goes with the instrument. So, for the graphical user interface, we double click on the icon and it shows the different data that we have collected. For example, here we are showing you a data from a hollow cone nozzle. This particular data shows the extinction that is collected at 6 different view angles. You can see at each one of these view angles, axis 1, axis 2, axis 3, 4, 5 and 6, what the extinction is as a function of distance from the center of the spray. This particular extinction is transient. So, in this particular scene, you can see as time goes on, the sprays keep fluctuating up and down. Once you have collected this particular data, what you can do is you can deconvolute that data in several different manners. For instance, you can first of all set what the spray angle parameter should be, i.e., how far away from the SETScan patternator you have placed your nozzle tip. You can also set additional parameters, like you can say you want to do the full domain deconvolution. You also want to deconvolute for the extinction coefficient or the surface area, and you want to deconvolute for the mean of the surface area. You can also do transient parameters, ensemble parameters. In other words, you can go ahead and analyze this data in a wide variety of places. For instance, the easiest way to analyze this data is to just click on the solver button. Once you click on the solver button, the entire graphical user interface is available to display the results in various ways. For example, this shows the surface area contours that are obtained. Here we have the x axis and the y axis. This spray is roughly about 50 millimeters total in diameter, and if you look at it closely, you will see that the surface area density is shown on this color scale. Areas that are red in color shows very high surface area density, and areas that are blue shows very low surface area density. In the center, you have a hollow cone. So, this is the basic picture that you get from the SETScan optical patternator. Once you have this particular picture, you can analyze this result in a lot of different methods. Let me show you a few of them. For instance, you can go ahead and see how the spray is distributed in an angular way. If it is perfectly symmetric, you would have got a straight line, but since it is not perfectly symmetric, you will see quite a bit of variation with angle. Similarly, you can also look at something like the radial distribution. As we know, in a hollow cone nozzle, the center, the surface area is very low, and the peak surface area is off axis in this particular case, roughly at about 9 millimeters. We can also see other types of things like the zone sector. The zone sector, if I could show you, it shows you exactly what percentage of the spray is seen in different locations. For example, in this particular case, you have 9% of the spray here. In this particular case, you have about 12% spray here. So, different percentages of the spray is shown in different ways. You can also find out how this percentages changes with time. For instance, so if you click play, what it will show you, it will tell you as a function of time how the different percentages are changing. You can see that if you go back to the contour plot, you can see there is a small rotation that comes because this is a swirl stabilized atomizer. In addition, you can see summary report. For example, you can see how the spray angle keeps changing with time. It varies from about 48 degrees to 50 degrees. You can see the total surface area, which is very important. The higher the surface area you have in a spray, the more intense is both the combustion and evaporation that you can get from that particular nozzle. So, if you have to select among different types of nozzles for a combustion application or a spray drying application, choose the nozzle with the highest surface area, total surface area. So, now that we have seen how easy it is to use the graphical user interface, I want to close that and go ahead and show you some examples to show you more in detail what is available from this patternator. So, now the first example that I have chosen to show you is an aircraft engine nozzle. Here we have the pattern output of an aircraft engine nozzle. This strut, first thing you will notice is the strut signature seen in the drop surface area per unit volume. So, the strut means here you have very low surface area density, here you have very low surface area density, here you have very low surface area density, and here you have very low surface area density. So, that shows you have 4 struts that are holding the nozzle up. Once the manufacturer saw this particular example, they recessed the struts further into the nozzle body, so that they could get a much more uniform contour of the surface area density. The second thing that you can see is a hollow cone nozzle is always seen as hollow. For example, here you can see the hollow cone nozzle in the right in the middle, you have 0 surface area density. And finally, there was a small drip in this nozzle at the center. The small drip is very small, we were still able to pick that up. So, it shows you how reliable and extremely accurate the entire system is, that it can show you small drips, it can show you small signatures of struts, it can show you where the peak intensities are, where the lowest values of intensities are. The next example I will show you is from an automotive injector. Here we have an automotive injector example. This is a GDI, or a gasoline direct injection systems injector. There are 6 plumes in that particular injector. The 6 plumes have different locations for them, and they have different angles associated with them. So, you can see the plume angles for all the 6 plumes. It can tell you what is the percentage split among the plumes. So, one of these plumes, for instance, has only 4.69, while another has 24. So, the amount of fuel being evaporated at this location is roughly about 6 times higher than this location. Similarly, it tells you where the mean location of the plumes are, both the x and the y location in that particular coordinate system. And that is very important, because what happens in all these direct injection engines is that you have to place the proper amount of fuel at the proper location, so that your engine operates very smoothly. If you go back to this example, you will see in one of those plumes the intensity is very low. So, what happens is, out here and out here the combustion is much more intense, and hot gases will rush towards this side and rush towards this side and create some sort of instability, which is not good for either emissions from the emissions viewpoint or from the engine stability viewpoint. The next example I want to show you is a paint spray. Here you have a flat fan paint nozzle. Paint nozzles are used in a wide variety of industries. They are used for tablet coating in the pharmaceutical industries, they are used for painting furniture, they are used for painting cars, they are used for painting almost everything that you see around you. So, here in the paint nozzle, what is very important is the width of the paint. So, here you see that the width of the paint is roughly about 4 inches. So, if you are painting a 4-inch object, you want to be roughly about 3.5 inches away from the object, or if you are painting something that is, let us say, about 5 inches, then you want to be about 4.5 inches. So, using the patternator, you can immediately find out in your painting operation how far away you need to put your nozzle exit from the object that you are painting. So, for all these different things, what you will see is the patternator will give you different information, like the major angle, the minor angle, the deviation from the center. The deviation from the center, what that means is, if you draw a straight line through the center of the spray, you can find out how much offset it is from this. This is very important. You want the offset to be very low, so that you are always painting right in the center of your object and not to the side. So, you can see how useful such a tool would be when you are doing a painting operation. You know exactly where to put your gun. you can put your gun so that you can optimize the coating, you can have very little overspray, and you can ensure that you are painting the entire object. So, now if you go to the next this thing, we have some concluding remarks. What we can find is the SETScan Patternator is very user friendly, and that it can be operated by a technician with half an hour's training. Second, the user interface provides extremely detailed and accurate picture of the spray, and we have shown that with 3 or 4 examples, and the output is useful in design as well as the inline testing of nozzles and injectors. Thank you very much.